So f of t, which is the distance, is t to the third minus 9t squared plus 24t. And they want the velocity and the velocity at 1, and when it's at rest, and then I'll come back after part C. Okay, so in part A, they want v of t, which we know is f prime of t, which will be 3t squared minus 18t and plus 24. And I want to always think in terms of factor simplify, so I have a 3 outside. And t squared minus 6t plus 8. And also I notice that I can quickly simplify this or factor this into t minus 2, t minus 4. And you can say, why are you doing this? It's not needed here, but I already read ahead, and I know at some point in time it's going to ask me about direction. So I already have it set up. So part B, we want to find v of 1, which is f prime of 1. Is this okay so far, everyone? Is this okay so far? So I have 3 minus 18 plus 24. So 3 minus 18 plus 24. So this is 27 minus 18, this is 9. Always check my numbers. Okay, I have to present the measurement unit. So I go back and share for a second to see seconds and feet. Okay, so this is in feet per second.
Can you slow down a bit? You did the derivative of the original equation, correct?
So this is the distance. The derivative of the distance is the velocity. Which is this. I factored out 3 and I factored t squared minus 6t plus 8. And as I was saying, this is not needed right now. Which part was not clear?
That third step where you have the t minus 2 and the t minus 4.
So when we factor a trinomial of this kind, we look at since the leading coefficient is 1 and the last number is 8, and this is the sum and this is the product. So the sum of two numbers who is negative 6 and the product who is positive 8. So this is 2 and 4, and this is negative 2 and negative 4. So both are the same numbers. So negative 2 times negative 4 is 8, and negative 2 minus 4 is negative 6. So then I know that using negative 2 and negative 4, I can factor this trinomial.
Thank you.
Other questions so far? Is part B okay? Anyone? Is part B okay?
Yes.
Perfect. So now part C, when is the particle at rest? Okay, so if you remember part C, where the particle is at rest, my car is sitting in the parking lot, which means the velocity is 0. That's the rest. So that's why we determine from here t equals 2 seconds and t equals 4 seconds. That's why I did this. Any questions so far?
Yeah, I have a question.
Okay.
I get part C. Can you explain part B again?
Yes. V of 1 means 3 times 1 squared minus 18 times 1 plus 24.
Oh, okay, you put it into the original, into the derivative. Okay.
And that's what we have here. 3 minus 18 plus 24.
I got it. Thank you.
Okay, so let's continue now. When is the particle moving in the positive direction? Okay. Draw a diagram to illustrate the motion of the particle and use it to find the total distance in feet traveled using the first 6 seconds. Okay, so D and E, 6 seconds. So I'm going to use the 0 to 6. So V prime of t and V of t if we need it. So we know that V of t is 0 at 2 and 4. Both of them are in this interval. So V prime is 0. And now I have to study the sign of this derivative. Well, just plug in 0 and you'll get positive. If you plug in 6 in the velocity, how do I know without even doing anything? Because this, if you picture the graph of this, the function has a minimum and crosses at 2 and 4. If it has a minimum and it crosses at 2 and 4, it's positive outside and negative in between. Yes, you can put this function in the graphing calculator and plug in 0, plug in 3, and plug in 6, and you'll see the signs. Okay, so for this interval, it's going the positive direction, negative direction, and positive direction. Any questions so far? We had two problems like this in class. I'm hoping, again, I always hope that my students go back and redo them after class. So in part E, the total distance is S of 2, or F of 2 if you want, S or it's the same thing, F of 2 minus F of 0, when it goes to the positive direction, plus F of 4 minus F of 2 in absolute value, and plus F of 6 minus F of 4. So can you plug them in and find the answer, or you still want me to finish up these numbers?
Finish.
Okay. So where is my calculator? So I have in y equals the function is x to the third and minus 9 x squared, and then plus 24 x, and plug in 0, 2, 4, and 6. So I have 20 minus 0. I have 16 f of 4. 16 minus 20. And f of 6, 36, minus f of 4, which is 16. Okay, so I have 20 plus 4 plus 20, which is 44. And this is feet. Okay, in the next question, we're asked to acceleration. Very good. So that's F. And find acceleration after 1. And then we can graph with the graphing calculator, speeding up and slowing down. Okay, so let's look at the acceleration and A of 1. So A of t is v prime of t and the second derivative, of t. And this is 6t minus 18. That's the acceleration. We're asked to find acceleration at 1, which is negative 12 feet per second squared. 6 minus 18. In G, they want the graph, and we can graph with the graphing calculator, of course. And in H, I think the last part, they want, yes, speeding up, slowing down. Okay, perfect. So for that, we are going back to the table we just created. I'm going to create it again. I'm going to copy it here. And here's T. Here's V of T. I'm sorry, I meant V of T, not V prime, not yet. Just V. Then the acceleration between 0, and we also need to determine when is the acceleration 0. Is 0 when t equals 3 seconds. 6t minus 18 equals 0 means t equals 3. So here's 3, here's 0, 0, and 0. I already have the signs for the velocity and the sign for the acceleration. It's a linear function with a positive slope. Negative goes to 0, positive. Or you plug in numbers. It's up to you. Whatever works for you works for me. So then between 0 and 2 is slowing down. Between 2 and 3, the forces are helping each other. It's speeding up. Here again, they're working against each other, slowing. And here they're working with each other, and that's speeding. So for slowing, I would write 0 to 2 union 3 to 4. For speeding, okay, of course this is down, you know what I mean, and up. And for speeding 2 and 3, union 4 to 6. Any questions? Is this okay, everyone?